All right, and so I'm going to start by showing you guys what I plan on getting done with you guys this week. I say plan on because I know some e-learning days could be thrown in the mix, but other than today, everything that we're doing past today is just going to be review. So I think we'll be good. Even if we have e-learning days, I think we'll still be able to get what we need done. So today we're doing rotations, which is our third transformation. We talked about translations on Thursday. We talked about reflections on Friday. By the way, the translation homework is due today. I did bump the deadline back a little bit to 4 p.m. There is a work paper for translations, but I will collect your work paper. I know some people have already emailed it to me. That's fine. I'll just collect it from you guys when we get back to school, hopefully tomorrow. I've got my fingers crossed. I'm kind of hoping for a 2-hour delay tomorrow, but because I'd rather be delayed than not have school and then have to do e-learning lessons. But
Mr. Bright.
Yeah.
Is the only work papers that we need is the 2.3 and the 2.1?
So 2.2 needs one as well. 2.2, your most of it is just writing down whether it's a translation or not. I know there's some problems where there wasn't any work because they just wanted to do it on the coordinate plane. But there was, if I remember correctly, 2 problems that you had to show arrow notation on the 2.2. On 2.3, the reflections, there was quite a few problems. And
yeah, I have it. Could you unsubmit mine because my 2.2 because I pretty sure I have a work paper, but I can't find it.
Yeah, let me do that right now before I forget.
Okay, thank you.
Yep, 2.2. All right, Caleb, it's unsubmitted now.
Okay, thank you.
Yep. Okay, let me go back to, there we go. All right, so tomorrow we're going to review all the different transformations that we've done so far, which will just be 3 of the 4. It'll be translations, reflections, rotations, and there's a transformation packet. If it's an e-learning today, I'll send you a digital copy of that packet. I did print paper copies off, so I'm hoping we're in school so you guys can do it on paper. I think it's easier to do paper and pencil, but I guess it doesn't matter a whole lot if we have to do it on Notability. On Thursday, I've got a review quiz that we're going to do in class. And then Thursday's homework is a mixed review of the transformations. So the reflections and the rotations and translations. And it's a geometry IXL. It's not in the 8th grade. It's in the geometry L.12. And you're going to get to a SMART score of 80. That would earn you a 100%. Anything that you do past 80 is extra credit. So if you take it all the way to 90 or 100, I just, instead of putting 100% in, you may get 110% or 120% on that homework. Okay. Cooper, what's your question?
When are we doing dilation?
Dilations will be after this quiz that we're taking Friday. So dilations won't be on your first quiz. Dilations will be on the next one because everything we've talked about so far has been congruent. We talked about congruence in section 2.1, and then they give you a bunch of congruent transformations. And what I mean by congruent transformations are transformations that don't change the size of the shape. After our quiz on Friday, Cooper, we will start talking about similar figures and dilations. Okay, so we'll do that. So quiz on Friday only has the transformations that we've talked about so far: translations, reflections, rotations. We're going to review Wednesday and review it on Thursday again. So the practice quiz won't be homework. We'll do that in class, and then the homework will be the IXL. And because it's an IXL, I can't put a lock on it. You guys could actually start that one now if you wanted to. And then I'll make sure you get your transformations packet tomorrow, even if it's an e-learning day tomorrow. Okay, so I'm going to share my notes. Go ahead and download the 2.4 notes to Notability that I posted on the e-learning lesson if you haven't done so already, and I'll try to get my iPad connected. All right, can someone confirm that they see my iPad screen?
I do.
Okay, thank you. Just make sure I don't do this whole thing and record this whole video and you can't see what I'm writing down. Okay, so we're talking about rotations today. And so a rotation turns a figure. We said that a translation slides a figure, a reflection flips a figure, but a rotation turns a figure about a point. And that point that we turn it around is called the center of rotation. Normally for us, that's going to be the origin. It doesn't have to be, but normally that it is. Okay. The number of degrees a figure rotates is called the angle of rotation. Okay, so we look at this first example here. Degrees was that last one. Okay, look at this first example here. It says you must rotate a puzzle piece 270 degrees clockwise. Now clockwise means you would be going this direction. So 270 degrees, remember it's 360 degrees would be a full rotation. 270 degrees would be 3/4 of one. Or you could say, and that's typically what I do, I don't really say 270. What I would say is it's a 90-degree rotation counterclockwise, which I abbreviate CCW, counterclockwise. So that's the same thing. And so they're rotating it around point P. Here's point P. So which of these puzzle pieces do you guys think has been rotated
C.
90 degrees? What do you think?
C.
C. Why do you say C?
Because if you turn it 90 degrees counterclockwise, it sits straight up.
You're right. And so if you turn it 90 degrees counterclockwise, it would have a little puzzle piece up here and then a little puzzle piece here. Both C and D have that, as you can see. Both C and D are still options then. But there's a little cutout piece here. And so if we do a 90-degree counterclockwise rotation, that little cutout piece would then be on the bottom. And so that would match with C, not D. So I agree. C would be the correct rotation. Okay. The other ones are either different rotations or just a different puzzle piece. Like example D, this puzzle piece doesn't exist. Like that's not the same puzzle piece. So it wouldn't be D. Okay. Which of them was a 90 degrees clockwise rotation? So go the other way. Which of them has been rotated 90 degrees clockwise?
A.
A. I agree, because then the little cutout piece, if you want to use that as your reference point, the cutout piece right there, that would have to go on top. And there's only one that has that little cutout piece being on top. So this one would be the 90 degrees clockwise rotation. And this one would be the 90 degrees counterclockwise rotation. Good. What would that make example B then? It is the same puzzle piece. So if you're not turning it 90 degrees clockwise or 90 degrees counterclockwise, you must be turning it
180.
180. Yep, 180 degrees. And that means that this piece right here, which I'll color in purple, this piece would be pointing to the left instead of to the right. This piece, instead of pointing up, would be pointing down, and the little cutout piece would be on the right side instead of the left side. Okay. Now notice that when we write 180 degrees, we don't say clockwise or counterclockwise because it doesn't matter. 180 degrees is halfway no matter what direction you turn it. Okay. And then we said answer choice D isn't even the puzzle piece at all. It's a different puzzle piece because that cutout is in the wrong spot. Many times we rotate figures around the origin. That's going to be our point of reflection or point of rotation. So if you are rotating around the origin, here's your cheat sheet, like we have for all of the different transformations so far. To turn blank, blank, blank around the origin, so let's say it's 90 degrees clockwise, there's two parts you have to do. Okay, the first thing you do is you take the opposite of the x coordinate, and then you have to flip the coordinates. So you do negative x, and then you have to flip it so that it's y comma negative x. So whatever the y coordinate becomes the x coordinate. Whatever the x coordinate was, make it negative, and then it becomes the y coordinate. Exact opposite for counterclockwise. Take the opposite of the y coordinate, so I'm right here. Take the opposite of the y coordinate, and then flip them. Okay? And then the easiest one is the 180 degrees. Take the opposite of both coordinates, but do not flip them. So x stays where x was and y stays where y was. You just take the opposite of both. So this is your cheat sheet. So there's 3 different types. If you follow this cheat sheet, rotations really aren't that difficult, although there is 2 steps you have to do for the clockwise and counterclockwise. What becomes more difficult is when you try to do it in the coordinate plane without the arrow notation. Okay, so for example, if I said, here's a triangle, guys, I need you to rotate it 90 degrees clockwise. Okay, that's what we're going to start with. Then we'll do 90 degrees counterclockwise, then we'll do 180 degrees. Okay, it's going to be very difficult to try to figure out where's this triangle actually going to go. Like, I'm not asking you to reflect it. That's something that's really easy. Translate it. That's also really easy. But to rotate it, you're like, okay, so there's my center. Here's the origin. And I'm going to rotate this. Where does the M go? Is it here? Is it there? Is it there? Is it there? And so that can be the hard part to see. And so what I encourage you to do, the reason we've done so much of the arrow notation is because I would do the arrow notation first. So when you're doing this on your work paper, I know that you don't have to draw the coordinate planes on your work paper, but you might want to put the arrow notation down on your work paper first before you start to draw on the coordinate plane. So 90 degrees clockwise. If I look at my cheat sheet up here, I know that clockwise means I take the opposite of the x coordinate and then I flip them. So the opposite of the x coordinate would make this -2, but then I have to flip it to make it 3, -2. The opposite of the x coordinate makes this -4, but then I have to flip it to make it -1, -4. Oh, I'm missing an arrow. Just realized this. Sorry, I paused this lesson to place an arrow right there on my little line. Okay, and then the opposite of the x coordinate here would make this -1, and then flip it to make it -3, -1. Now, because it's arrow notation, I need to have something written on the top of my line right here. And so I don't need to write 2 different things, even though there's obviously 2 different steps that I'm doing. I just need to write one, and it's going to look like this. Okay, so I'm going to write y, comma, -x. When I see that, that tells me that you've just done a 90 degrees clockwise rotation. You took the opposite of the x, and then you just flipped it. So that's what you have to write on the top arrow. Now that I know what the coordinates are supposed to be, now I don't have to guess. I can go right over to 3, -2. Oh, I guess last time I was doing counterclockwise when I was looking up here. We're doing the clockwise first this time. So it'd actually be moving it this direction, right? Down here into quadrant, that'd be quadrant 4. Some of them will be moving over to quadrant 3. Okay, so that's 90 degrees clockwise. So I'm going to graph 3, -2. There's my new M prime. -1, -4. There's my new N prime. And then -3, -1. There's my new P prime. And then I can connect it. And so that triangle has now been rotated. Again, kind of hard to figure out where it would go unless you use the arrow notation. Take the opposite of the x coordinate and then flip. Okay, now let's move to the 90 degrees clockwise rotation. Counterclockwise, sorry. Can't read my writing there. Counterclockwise, CCW, counterclockwise. Okay, this time it's going to take the triangle and move it this direction. So according to my cheat sheet, that I should refer back to a lot from my notes today. My cheat sheet says that a counterclockwise rotation takes the opposite of the y coordinate and then flips them. The way that I remember this is to me, clockwise comes first. You take the x coordinate first. You flip it first, or you take the opposite of it. Counterclockwise is listed second, just like the y coordinate is always listed second when you write the coordinate point. Okay, so that's the only way I've figured out to try to memorize that. So I'm going to take the opposite of the y coordinate and then flip. So it's going to look like this. Opposite of the y coordinate and then flip it. So I take the opposite of the 3 and then flip it to get -3, 2. Would someone like to try doing the n prime coordinate? What would that be?
1, 4.
Good, yeah, take the opposite of that -1, which becomes +1, and then flip it, and it becomes 1, 4. And somebody else want to try the last one? What's the p prime?
3, 1.
Good job, 3, 1. Okay. Take the opposite of the y coordinate and then flip them, right? That's what we did. So now I can graph it without guessing where it's going to go. The new m prime coordinate is going to be at -3, 2. It's going to be right there. The new n prime coordinate is going to be at 1, 4. And the new p prime coordinate is going to be at 3, 1. It was down there in quadrant 4, so it's going to shift up to quadrant 1. Okay, so that's what that triangle is going to look like now. Am I going too fast? Is everyone able to follow along so far?
Yes. Yes, I'm able to get.
Okay.
No. Fast.
Okay. If I am going too fast, remember guys, I am going to post a YouTube video of this later. So you could go back and watch the part you missed if you need to. You can rewind, fast forward as much as you want. You can even play me in half speed if that's going to make you, or double speed if I talk too slow. You might have to use the YouTube web browser. I don't know if it lets you do that on the app or not, but okay, and then the last one we have is the 180-degree rotation, which according to my cheat sheet, that's the easy one. That means I take the opposite of both coordinates, but I don't flip anything. Okay, I'm not going to flip them for 180 degrees. So I just take that means this is going to be -2, -3, no flipping. -4, +1, no flipping. -1, +3, no flipping. And so 180-degree rotation, the new m prime unit point is going to be at -2, -3, down here in quadrant 3, the all negative quadrant. So 180 degrees, this thing's going halfway around the circle. The new n prime is going to be at -4, 1, so up here. And the new p prime is going to be at -1, 3. Let's move you over here. Prime. -1, 3 is going to make it right there. That's going to be my new p prime. So I draw in this triangle. And it kind of looks like it's been reflected, but it hasn't. Okay, it hasn't been reflected. Okay, it's been rotated 180 degrees. If it had been reflected, the m prime unit, since the m is over here 2 spots to the right, it'd be over here 2 spots to the left, and the m prime is all the way down here. So you can tell it's been rotated and not reflected. Okay. Those are the 3 different types of rotations that we have. And again, what makes this difficult is just the part that you can't really, it's harder to visualize before you do it. So although, yes, I can understand when we did the translations and when we did the reflections, and then when I said, okay, you need to use arrow notation, a lot of you guys probably graphed the points and then did the arrow notation afterwards. I get that. You can visualize those better. For rotations, you're probably going to want to do the arrow notation first. Then you don't have to guess where the triangle should end up. You can just plot the 3 points after you use the arrow notation.
Mr. Bright,
Yes.
I have a question about the arrow notation. So
Sure.
do you want to put all the letters and then the points and then the arrow and then the letter primes and then the points?
You don't have to. If you don't
Or
want
do you
to,
just,
yeah, if you just want to put the coordinate, you don't want to write the letters, that's fine. That was my way on the notes of keeping track which point was which.
or do you just want to put us like, could we just put -y, x?
So what you would need to do, the bare minimum, by the way, I just realized, thanks for reminding me, Caleb, I did not write it on top of this arrow. This one would be, there was no flipping, just -x, -y is what we would write here. Okay. The bare minimum of what I would need, I'm going to go ahead and highlight it. Oops. That's the bare minimum of what I would need, Caleb. I would need the
Okay, because I was just putting the just x and then the y.
Okay. Yeah. So write down what they were.
Okay.
Write what you're doing to them on the top arrow, and then write down what they are now. Does that make sense? If you don't want to label them as ABC, MNP, QRX, it doesn't matter to me. And so that's really the work I'm looking for on your guys' work papers. So if you didn't do that on the translations homework that's due today, you only had 2 of them anyways, I wouldn't worry about it. Just make sure you're doing it on your reflections homework and your rotations homework. And if you need me to unsubmit something, let me know after class, I can do that. Okay, let's go on to this part. This part, they're just giving you, they're describing the type of rotation, and we have to tell what type it is. So we want to be very specific. You know, if it was a translation, I got to say how far to the right and left, how far up and down it's moving. I can't just say up 4. I got to say translation up 4 or whatever. If it's a reflection, I got to tell whether it's an x-axis or a y-axis reflection. So I write reflection x-axis or y-axis reflection, whatever you want to write. Same with rotations. I want to say that it's a rotation, but then I have to give the degrees and the direction. So I know this is a rotation. You can abbreviate that. I know it's a rotation. What kind of rotation just takes the opposite of the x and y, but doesn't flip them? Think about the rotation we just did, where we took the opposite of the x and y, but didn't flip them. What kind of rotation was that?
A 180%.
Okay. Nuche, thank you. 180. Yeah. So 180 degrees. And this is the only one where you don't have to give the direction on it because it doesn't matter. It's 180 degrees. It's halfway no matter which way you go. Okay. What kind of rotation takes the opposite of the x coordinate and then flips them? If you have to, use your cheat sheet.
90 degrees clockwise.
You got it. Nice job, Elise. 90 degrees clockwise. Oops, don't want to close out of that. And you can abbreviate clockwise as CW. Okay. All right, now they're, instead of giving us X and Y's, they're getting us real numbers. Let's see what's happened here on example C. It looks like they took the opposite of the, it looks like they took the opposite of both of them, but didn't flip them. So what kind of rotation would that be? They took the opposite.
80.
Yeah, 180 again. Yeah, 180 degrees. Good job. Huh? I'm gonna have to start calling on some people because I'm not getting a lot of responses. Claire, I haven't heard from you today, Claire. Whoops. What happened to my screen? Go back. Can you guys still see my iPad?
Yes.
Yeah.
Yeah.
Okay, Claire, what kind of rotation would take the opposite of the y coordinate and then flip-flop it?
90 degrees counterclockwise.
You got it. Rotation 90 degrees CCW. Counterclockwise is the abbreviation for that. Good job. Okay. And then what about this one? This one's a challenging one. We'll think about it for a second. They definitely flipped them, right? I can tell that they flipped them. So I know it's either 90 degrees clockwise or 90 degrees counterclockwise. Can you guys even tell? What do you think, Levi?
I think it's clockwise.
Why do you say clockwise?
Well, because the -5 has stayed the same, but the 0 can't become negative.
Ah, so you're saying that because the -5 is the same, they definitely didn't do the opposite of the y coordinate and flip it. You're thinking they did the opposite of the x coordinate and flipped it, and that's why it stayed as 0? That is correct. 90. Nice job. That is a rotation of 90 degrees clockwise. They took the opposite of the 0, which made it 0 still, and then flipped it. And we can tell because, as Levi said, we know that they flipped it. We know that there was a flipping, right? So we know it was either 90 degrees clockwise or counterclockwise. If it was counterclockwise, this -5 would have become a +5. And so since that didn't happen, it must have been the 0 that they did the negative of. Okay. I'm going to skip this for right now. We don't have time to cover a rotating around a vertex. I will probably come back to this tomorrow, assuming we're back in school tomorrow. So I'm going to leave that example for right now. And I'm going to probably see how long we have. I bet you we could do the next 2 examples really quickly. The next 2 examples have 2 different transformations that have happened. The first one was a 90 degrees clockwise rotation. The second one is a reflection around the y-axis. So a 90 degrees clockwise rotation is going to take the opposite of the x coordinate and then flip it. So that's what I would write on my arrow. Okay. And I got to admit, when you do these questions in the notes, it is a pain to have to write it all down. I get that. But it is going to make it a ton easier for you guys to get the answers right. So when I'm converting this, I'm going to make this a -2 and then flip it. Going to make it a -4 and then flip it. Then I'm going to make it a -1 and then flip it. Okay. Now let's do the reflection. Can anyone please tell me, do you remember back from Friday, what happens when you reflect a point over the y-axis?
The x coordinate gets negative.
Yep, you take the opposite of the x coordinate, but nothing changes to the y coordinate, and you don't flip them either. So we flipped it once already. That was for the rotation. We're not going to flip them again. We're just going to take the opposite of the x coordinate. So this is going to become -3, -2, +1, -4, +3, -1. And now we have our answer, our 3 double prime coordinates. And if I was supposed to graph this on a coordinate plane, I would be able to do it now that I know what the coordinates are. I'll leave this up here for just a little bit longer, and we'll do one more example like this when you're doing 2 different types of transformations. And then I have that one problem I'm going to go back to tomorrow, and then I'll probably have, I think there's one more down at the bottom I'm not going to get to, so because we're only doing 30-minute class today instead of 45. I've been doing pretty good though. I have to admit, the notes have been able to finish on time. Even when we had 2-hour delays, we were able to get our notes finished on time. But
Mr. Brian,
notes are a little bit longer. Yeah, what's
are
up?
you going to leave the Zoom open for questions?
I can't. My wife will need to use the computer for her Zoom, but I'll be available all day long via email. And as soon as her Zoom's over, I can answer any of your questions via Zoom as well. Okay. But she's got to borrow the computer for her Spanish Zoom class. Okay, we'll finish up with this last example here. It says the vertices of the triangle, well, these are the vertices, which I've already written them down for you. I've done the work, the first part for you, writing them down. It says they're going to rotate it 180 degrees and then reflect it. Ooh, this might be a challenge one. They're going to reflect it over the line y equals x. Okay. So when I rotate 180 degrees, that doesn't flip anything, but it does make them both negative, or at least it takes the opposite of both, is maybe what I should say, right? So I'm not going to flip. So when I rotate 180 degrees around the origin, this -1, 2 is now going to become 1, -2. -1, 0 is going to become 1, 0 because I can't take the opposite of 0. It's just going to stay. And 2, 0 is going to become -2, 0. Now, you can look back if you want to, but can anyone tell me what happens when you reflect over the line y equals x? You'll find this in your cheat sheet on the 2.3 reflections notes we did.
You they flip places.
They flip places, exactly, yeah. So even though 180-degree rotation is the only rotation that doesn't flip places, then when you reflect it over the line y equals x, you have to flip the places. So I'm not going to make, it doesn't take them the opposites though, right? It doesn't do anything with the opposites. It's just literally going to be y comma x is what I would write. Anytime I'm doing a reflection over the line y equals x, I just flip-flop them now. So 1, -2 becomes -2, 1. 1, 0 becomes 0, 1. And -2, 0 becomes 0, -2. And then if it wanted me to plot, to graph triangle PQR, I would be able to graph it now after both those transformations. So arrow notation, although somewhat time consuming, I get that, it is your friend. It does help ensure that you have the right coordinates without having to guess. So tomorrow we will do this, I don't know, I need to think about it. If it looks like we don't have time, I might just take this off and cancel that homework question. We'll see how tomorrow goes, but I'm going to finish this problem in the notes where instead of telling you what the transformations are, this one tells you that there were 2 transformations, but it doesn't tell you what they are. It just gives you a picture. And so we'll figure out if we can try to, figure out, there's maybe a couple different ways. In fact, there are 2 different ways that you could get the blue image to be the image of the red figure. So we'll talk about that tomorrow. All right, so I'm going to post this video on YouTube. If you missed something, get started on your 2.4 homework, and remember that 2.2 translations is due today at 4 p.m. now. The reflections one's due tomorrow at 2:30. If we have an e-learning day, I'll bump that deadline back, but if we don't have an e-learning day, it's going to be at 2:30. You guys might have noticed real quick before I leave, you guys might have noticed, did I write it down? No, I didn't write it down. On the lesson plans, I wrote down that the 8th grade schedules with Mrs. Price was supposed to happen today. That was also for you guys too. We were going to do that during success time today. And so Mrs. Price was going to meet with you guys in the cafeteria. She was going to show you guys how to schedule, how to sign up for your 8th grade classes. Many of you guys have been asking me like, okay, how do I sign up for Spanish? How do I sign up for French or Japanese or whatever? That's all going to happen. She has rescheduled this. This is now going to take place on Friday during success time for you guys. So at the end of the day, Friday, she's going to give you guys papers to take home so you can talk it over with your parents and you can decide what your classes are going to be. As an 8th grader, you get to choose what encore classes you want to take. So you still have to take math and science and language arts and social studies, but you get to choose your encore classes for the 9 weeks. Now, if you're in choir or if you want to take, for example, a foreign language in choir, well, that's already done. You get to choose those 2 things, but those are all year long classes. So Anyway, she'll talk more about that with you guys on Friday, but that's, if you notice that it was supposed to be for all you guys. If you notice that on the lesson plans, that's what that is. So if you have questions over that, or if you have questions over any of the homework, please let me know and I will either email you or we can set up a time to Zoom later this afternoon. Okay, that's it. You guys are dismissed. See you guys.
Mr. Bright.